Okay, so for example number 9, we are given here f sub 1 and f sub 2, two forces, and we are to determine the magnitude and direction of the resultant force. Okay, so resultant force, magnitude, and direction. Okay, magnitude and direction of this f sub r. Okay, so for us to determine the magnitude, okay, hindi naman siya specify kung nasa Cartesian, i-express ba natin siya sa Cartesian notation or not. Okay, so we could use any method in order to determine the f sub r. So in this case, we'll have to get the f sub r, the magnitude, okay, solving for magnitude, we have to what? We have to determine first the x components, or it is simply the square root of the sum of the squares of each of the exponents. Okay, or simply this is your summation. Okay, so frx is simply solved by summating your x components. So since you only have 2 here, so we will determine each of the x components of f sub 1 and f sub 2, or this is simply your f1x plus f2x. Okay, while for your fry, you simply have to summate all your y components. So f1y plus f2y. And in order to do that, so let us analyze each of the forces here. So let's solve first for f sub 1. Okay, so for f sub 1, so here's our force, which is f sub 1 600 Newton. So obviously the x component is right here. This is f1x. We are given the angle 30 degrees. This 30 degrees, as you can see, is with respect to the x-axis. And this one is our y component. Okay, so in order for us to solve for the x component, so what trigonometric identity should we use? So obviously f1x is adjacent, so given your hypotenuse, so therefore we will use cosine angle, that is adjacent over hypotenuse. Or in this case, our angle is 30 degrees, adjacent is f1x, and hypotenuse is f sub 1. So therefore, our x component is f sub 1 cosine 30. Okay, substituting, we have 600 Newton times your cosine 30 degrees. So substituting, class, using your calculator, so we have 600 cosine 30, and that is 519,615. And the unit is what? The unit is in Newton because the given is in Newton. Okay, so this is only the x component. Now, how about for the y component, class? For the y component, so looking at the figure, so FYI, if 1i is opposite of the angle, and here is the hypotenuse, so we will be using the sine sine theta is opposite over hypotenuse. So we have sine 30, opposite is f1y, and the hypotenuse is f sub 1. So f1y is f1 sine 30. So substituting 600 Newton sine 30 degrees. Okay, so we'll have it 600 sine 30. We have 300 Newton. Okay, now how about for the force 2 or F sub 2? Okay, so let us draw the figure or the force of F sub 2. So F sub 2 is like this. This is our F sub 2. But take note, class, that our given angle is with respect to y. Okay, is with respect to y. So this is the angle given, 45 degrees. Okay, 45 degrees. So obviously this part right here is the y component of F sub 2, and this part is your x component. Okay, this is f2x. f2x. There. So based from the given angle, okay, how are we going to determine the x component? There. So the x component is opposite the angle. So from that, okay, we will be using sine theta. Okay, opposite over hypotenuse. So therefore, sine 45, the opposite is your f2x or your x component divided by the hypotenuse, which is f sub 2. Okay, so your f2x is f2 sine 45 degrees, or our f sub 2 here is 400 Newton times sine 45 degrees, and therefore your f2x is 400 sine 45. We have 282. 843. The unit is in Newton. Now for the y component, so since the y component is adjacent of that angle, so we'll be using cosine. So cosine 45, the adjacent is f2y, and the hypotenuse is f sub 2. So therefore f2y is f2 cosine 45. So f2 is 400 Newton cosine 45 degrees. So we have 400 cosine 45, 282. If you can observe, they are just the same class. Why? It's because in a 45-90 triangle, the side is the same. Okay, Newton. There, the side, this one and this one are the same. Okay, so there you go, our x and y components. So once we know the x and y component, we will now substitute it here to get the total sum of the x and the y. Okay, so I have here made a copy of the values of the x and y components of each of the forces. So we will now solve first for the frx, okay, by simply adding our x components. So we have f1x and f2x. So we have here, by the way class, before we do that, so recall that our components should carry their respective signs or directions. So looking at the figure, okay, our f sub 1 is going to the right and going up. So obviously the f1x and f1y are both positive, okay? But here in f sub 2, your force is going to the left but going up, okay, up but going to the left. So obviously the negative there is the x component, okay, so there will be a negative there. So substituting, your f1x is 519,615 Newton plus your f2x, which is minus or negative 282,843 Newton. Okay, so therefore the value will be 519,615 minus 282,843 there, and you'll have 236.772 Newton. Okay, positive. For the FRY, so summation of f sub y equals f1y, f2y. Okay, so we'll have f1y is 300 Newton plus your f2y is 282,843 Newton. And you'll have 300 plus 282,843. 582,843 Newton. Okay, so that's our FRX and FRY. So to solve for the magnitude of resultant force, we will use the Pythagorean Theorem. Okay, because class, if we plot this in the Cartesian, say since both of them are positive, so if we plot that, this is our FRX rather, and our FRY is like this. This is our FRY, sorry. So therefore the resultant force is this one. Okay, this is our F sub R, and in order to do that, we'll be using the Pythagorean Theorem. So F sub R is simply square root of FRX squared plus FRY squared. Substituting, 236,772 squared plus, don't forget the unit, plus 582,843 Newton squared. So we have to get the square root of this, and that would be your magnitude of F sub R. Okay, so square root of 236,772 squared, 582,843 squared. So we will have 629,100, and the unit is Newton. It's because class, once you squared the newtons, Newton squared, and then cancel that out when you get the radical. So this is already class our answer for the magnitude. Now how about for the angle or direction of your F sub R? So this is your F sub R, and we can only describe it using an angle. So as you can see here in the figure, we can have our angle with respect to x, which is right here. Okay, and in order to do to solve for the theta, so given this FRX and FRY, so this is adjacent and opposite and adjacent. So therefore the appropriate trigonometric identity to be used is the tangent. Okay, so I'll be erasing this, and we will solve for theta. Okay, so using the tangent theta, so tangent theta is opposite over opposite over adjacent there. So our target is the theta. So in order to do that, we'll have it divide by both sides by tangent, or that will become arctan opposite over adjacent. And in this case, class, our opposite is what? Opposite is your FRY, or the magnitude of your FRY divided by your adjacent, which is the x component. Can you follow? So therefore, substituting, okay, arctan of FRY is 582,843 Newton divided by FRX 236,772 Newton. And using your calculator, so we have arctan, and then 582,843, 236,772. There. Okay, so the angle is 67.891. There. So the answer, class, for the direction is 67.891 degrees. Okay, now question, ma'am, can I use cosine theta or sine theta here? It's because, ma'am, I have already solved for f sub ra. Can I use it? Kasi pwede naman, diba? Kasi meron naman adjacent tsaka hypotenuse, or maybe opposite and hypotenuse. So can we use it? Well, class, pwede. But when it comes to accuracy, so we don't take the risk. Why? Kasi, class, the f sub r here is a solved quantity. Kasi solved quantity, ito siya. So kung halimbawa na magkamali ka sa pag-solve dito, diba? Anyways, yung f sub ry tsaka f sub rx are also solved quantity. Yeah, oo. But most of the time, ito talaga yung pinaka best na formula to be used in solving the angle. But also, of course, you can use cosine theta and sine theta for that. O, kasi adjacent using the frx and the fr. Okay? Pwede siya. Pero for halimbawa sa problem na given agad yung x component tsaka y component, tapos pinapasolve sa inyo yung angle, so much better if you just use the tangent theta.